A lot. Thanks a lot for joining us in this cold evening. We're going to do this session for Design Patterns course. Today, let me remind you that this course delivered for you by me, lead software engineer at JP Morgan Chase, by Sonali Goel, who has 14 plus years of experience with e-commerce solution. Leslie, who have 5 years experience in software engineering and right now specialize in Python and Django. So we have quite good content because it's reviewed several times. And we hope that this course will be super helpful for you, especially even if you first time ever learn design patterns or you work with Python, not Java. That's this book about Java, but we also have example in Python. Okay, and let's first of all start with more interactions with you. Let me ask you, what do you remember from previous sessions? And let's start with the most interesting questions. Why do we need behavioral patterns? In your words, without any strict explanations. I checked twice Wikipedia and official resources. I wouldn't say it's very clear from very official of patterns determination what exactly they are about. It's the wording is not how I would explain. So try to explain in your words. What do you think? What is your thoughts? Okay, Narmin.
Hello. Basically, what I understood from our sessions and from my experience, it's basically how the objects interact with each other, how they behave under collaboration during the control flow of the application. So imagine we have a system and we want to manage this flow of the control in a system so that the objects under collaboration, in a flexible way can interact with each other. It basically focuses on, how we can improve the complex behavior of the software systems in a chain, let's say.
Yes, I would agree with it, with everything. Pratna, anything to add?
Yeah. From what I understood, behavioral patterns are required when different kinds of objects are meant to behave in a similar way, and we can build a kind of a flow between them, which is common in spite of the objects being different to each other, and that way reducing code redundancy.
Yeah, it's very good. Yeah, it's very good compliment for what has been said. Not only just behavior, but also the way how they interact similarly within the system. Like we have several objects that do behaviors that we understand we can replicate them. And that's great because of it, we could derive the pattern of their behavior. And that's where behavioral pattern is coming. So you absolutely right. Who would like to try to take structural patterns and explain what is the difference to behavioral one? Just in your words again. Yeah, Pratna.
So structural patterns would they focus on the attributes of the objects and the classes, meaning what properties they have, and class is like basically a template of what those objects might be, whereas behavioral patterns is more about how, as Narmeen said, that it's more about how they interact and collaborate with each other.
Mhm, mhm. Okay, I would say in a bit different way. I would say the behavior is the same. We don't need, okay, Rachel, try. Yeah, Rachel.
Yeah, I just want to try. I think the behavioral patterns is, I see it as like the relationship between the objects, and structural patterns is when you begin to build something bigger between the classes. So, like an adapter, for example. I think of it more as maybe structural patterns have to do more with the interfaces between classes, or you might think more about interfaces than the relationships between the objects. I don't think this is clear, but
Yeah, almost. I think it's almost there. So again, indeed, behavior, it's about we have different objects. They have some relationship between each other, and there are patterns that can help us to understand those relationship quite quickly through pattern, and also reduce repeatable operations because we apply this pattern. While structural, it's about we already have existing behavior, but we need to change it somehow. We need to change the behavior. We need restructure this object. It's not about how different objects interact with each other. Indeed, it's about how objects interact. We need this behavior, but we need to change it in some way. So in case of decorator, we remain the same behavior, but we restructure it by adding new features, and we do it through decoration, through this pattern, by adding new layers. And in case of adapter, we again already have behavior, but we need to adapt it to another system. So we restructure the way how the object behave. Behavior already exists, but we need to define a new structure, keeping the same behavior. Helpful? Okay, good, good. Okay, thanks a lot. Who would like try to get and explain creational patterns? Okay, Dennis, let's go.
Yeah, I can try. Creation of patterns is more about this is the perfect solution for a factory pattern. Like you have a basic a product, let's say basic product, then you can from the basic one you can create with different behavior, with different features, products, a different type of products from a basic one. So this is what I think about a creation of pattern. From a basic product to have a base of from which one to move on and create different ones.
It's a good point of view. So I would rephrase a bit to have baseline for all objects where they created. Yeah, so to build basically foundation of your application before they will start interact or be decorated. Yeah. So we first of all treat. Yeah, super. I like this answer. Anyone would like to rephrase or add anything else? Okay, if everyone happy with it, let's go for last questions, and that's about our patterns that we discussed last session. So first of all, what command as a pattern is useful for? I would like to answer this. Maybe what was two additional things that we added to objects, to their behavior again, that is different to other objects. Yeah, like what was a difference, a small difference for command pattern? Yeah, Narmin?
Basically, what I understood that let's say we have one action, I would say one method, let's say the command interface which defines, and it's one action, but it can have different implementations with a concrete implementation. But we have another receiver object, which these objects, since they call this concrete implementation, basically it's kind acts of as a receiver, so we can chain this receiver's action to the concrete implementation, basically. So it's useful when we want to encapsulate the request with our objects, basically.
Mm-hmm. Yes. But then, as we discussed, I think, as you remember, what will be different to observer pattern? Because observer is also about receiver that would like to find out about actions that's happened.
Yes, but in that case, list of the observers, observer should know list of observers. Basically, it should be registered on that. But in that case, observer, basically broadcast these updates to all list of the observers who observe this. The concrete abstract implementation. But this is not a case in that case, in this pattern.
I would say it's different approach for observers still. It's still like you still could go with observer pattern, just changing the name of, instead of action, you have action listener. And that will be more like observer pattern. There are small details that's making this common pattern to be different. Pratna?
From what I remember, the in the command pattern, the action is encapsulated separately, uh, so that all the other objects who want to invoke that particular action have a common way of doing it. And I think another thing was that the action is an undoable action, is what it said, that it can also be reversed.
Yeah, yes, that's what I wanted. So comment something very useful specifically when you have not just these actions, but you need to cancel them and you need to have a history of them. Basically order it with, for example, stack data structure, like we say which one comment was the first, and then we give ourselves opportunity to cancel these comments one by one. Again, like it's something that you need if you build editor, so it's not that common to have cancellation options for your system. However, that's exactly about this pattern. What exactly it make it really different to others? If there is no other way to think about it, because you need not only comments, you need also history, and you need this do action execute, but also cancel. We can also think that runable in Java, which is getting task, it's also kind of command, and future that you could also execute in parallel. It's also kind of wrapper for command. And for future, you could cancel it. If you ever try to use future interface, you also can execute and cancel future. Even like it doesn't have to be history of them, but that's some classes that you could remind for yourself if you would like to discuss command as like what exactly already implemented in Java. Okay, and let's go for the last question. Adapter. So who would like to describe where adapter is applicable? Yes, Dennis?
The adapter is the perfect structural pattern. It's the one that actually allows you to transform the input into whatever format you would like to. The example I think we used the last session was either converting the input to a JSON or to whatever structure or format you would need for later on computation. So, yeah.
Yeah, perfect. Thanks a lot. Okay, you are good listeners. Thank you for this. Let's discuss next patterns today. I hope this session will be enjoyable because today's pattern, they are quite straightforward. So let's go through them. First of all, facade, and let's place it. We already know that there is creational, we know everything about them. We know about some behaviors, we know about some structural. So where a facade is, it's structural pattern. And in my words, how it says, how I would describe structural, we do not change existing behavior of original action, actor, entity, whatever, but we create a pattern for the structure to add new behavior or change behavior by adding a new layer. So let's see how Facade will try to do this. So if we go to example in our book, we have Dream TV, and we do not want to do theater lights, up and down screen, etc. We just want to play. I want to see a show right now, TV show right now. So how Facade is useful for this? Facade provides a unified interface which encapsulate set of interfaces. It's higher level interface, it's abstraction to isolate different systems and make it interact as a one system. So that will be easier to use. And class diagram is amazing. Like there is subsystems, there is facade that know how to invoke them, and clients that do composition, basically have field, facade, and run action from this facade class. And that's it. Let's go also to check examples with our book, not a book, but Refactoring Guru website. And again, facade is something where we have many subsystems and we just want to hide them. Like in very abstract example with pseudocode, it will be video converter that actually do a lot. It's change not only the video file, but also audio, also codec. It's do some compression, etc. But for us, it's just convert video, and that's it. So that's also a good example. And I think what I would like to highlight today is that when you consult with this website, When you read the pattern, you can go to this website and also check relations with other patterns. So when we didn't know a lot of them, it wasn't interesting for us. But now, because we've learned some patterns, now we can think, okay, is there any relations? Are they similar? And why are they different? And let's see. First of all, we look at this and we think, it's remind us about adapter and good clues that they both structural patterns. And they may be different because adapter, when we think about one object, while facade, when we think about several objects. So that's 2 points, 2 hooks that help us to think about difference between them. Yeah, then. Now we remember the pattern, creational one, abstract factory. We already know about them. And we think, okay, we basically create a lot of objects and we created the factory to hide subsystems that create those objects. So basically, it says an alternative to facade, like one of the use case, and this use case is different because it's on the moment of creation. Yeah, so we can even think about, when we create objects, it's actually the same thing. It's either factory that created them, either facade that created them, just factory to create. It sounds a bit more familiar with creation, some factories that's created for us. We didn't talk about polite wait, so I will skip those. But I would like to also highlight this moment that facade class can be transformed into singleton. And why? Because we would like to have only one facade in our system. We don't want to duplicate them because they may accidentally duplicate subsystem classes. And for example, if subsystem classes, it's our connections to database or HTTP clients, we may duplicate these connections, we may duplicate sockets, we may consume much more resources. Because of it, very common to think about facade as a singleton. Okay, there is small questions. Let me have a look. I would like to ask where we can implement the learn patterns if you are front-end developers that don't work with TypeScript. Yeah. Have you been in our creational patterns session? Let me know. Yeah. So remember that we discussed about object-oriented patterns and functional patterns. When we're talking about JavaScript, TypeScript, Python as well, we also talking about functional as a first-class citizen languages, which means that indeed patterns will be a bit different, but the idea, very high level idea is the same. So when we think about some front-end services, you still may operate with complex subsystems. And when you think about facade, it's about simplifying, again, your interfaces, simplifying your classes, your code functions through models that separate you from knowing everything about subsystem to just 1, 2 methods. And we will go just right now to Python example as well. That means that even with TypeScript, JavaScript, with functional languages, you still think about the concept. And in case of facade, you have another library that could be written in Python, in JavaScript, in Node.js, in TypeScript. And this library, for example, establish connection, HTTP connections, and do a lot of things send request, get response, but maybe do actually more things like authorize, request response, upload, payload, etc. So because you don't want to expose all methods of this library, you build facade between this library and your code base. You build facade because then it's much easier, not only for you, but for everyone who is going to continue to work with your code base, to know what exactly methods you need basically to access. And you can do even something like platform libraries that will work exactly for your company, that will be facade between these frameworks libraries and your code base in your company. Why it's useful? Because in this case, you're telling your other colleagues, you know, these 2-3 methods, they work very well. Or like, I encapsulate 2, 3, 4 methods in one method because, again, they work very well. And I think we wouldn't need more methods. And if you ever would like to get other methods from these framework libraries, let's talk and let's first apply them in like test mode, because we want something very robust to go to production. So we first will discuss. And only if we would find out these methods are good enough, we will add them to facade layer. And then we will go next, continue to work with this facade, and then everyone else, all our colleagues will be able to also get access to this method, but only through facade. So facade basically protect us from any problems in vendor libraries, in vendor frameworks, in anything. And it doesn't matter what language is it. You can think about this pattern with functional languages as well. Thanks a lot for your reactions. Okay, good. Let's quickly check Java example and what we have here. It's okay, it's the same video library, so it's the same idea, but what I liked here that basically it's where you can find it in core Java libraries. And again, why I was talking about HTTP, because it's already had some external context that have a lot of things, servlet context, HTTP session, etc. And that's something that you could use to highlight. They are not that modern, but that's one of the examples. Right now, when you use even more high-level frameworks, under the hood, they hide in all these layers of primitive Java core libraries that do all these things. But now they build facade and then another facade and then another facade. So at the end of the day, we just do get, post, put, delete, and that's it. And we live happily forever. We don't need any more create servlet context, create HTTP session, create HTTP servlet request. 20 years ago, we would have to do everything of it. But today we live in this beautiful world of frameworks. And still sometimes, as I said, we maybe want our own facade to protect ourselves from maybe older frameworks or maybe 2 new frameworks that are not tested yet. So we build facades to be very accurate in production and to let know our colleagues which one is trusted API, which one is not yet or not anymore. Yeah, and I would say that this Java example is good. When I go here to Python example, I'm unhappy because, again, they say just operation, just subsystem. So they basically use it as pseudocode to explain the idea. But that's why we built our own example in Python. Thanks to Leslie for this. I return to slideshow mode. And here is a very similar example to what I was talking about. Now let's think about Jira API. And maybe you have it in your platform libraries. Maybe you use Jira API to automate some tasks. It's a very common example. So we are looking at Facade in real time, in real life. And let's think about what Jira API could have. It's create organization, add organization, user exists, create user, add user to organization, add to service desk. So let's say that we don't need everything to invoke directly. And we also can do some things even smarter by already use database manager, not only Jira API. So we can build even very smart facade. We can say that our Jira API is our Jira API, yeah, facade class Jira manager. And also, when we know that we set up organization, we need not only create it in Jira, but also save in database. And again, we add customer. We not only add customer to Jira API, but also we save it in our database. And the same for, yeah, it's just what database manager do. Yeah, like it's very simplified, but it's clear what was the idea about. So now we've built this even smarter facade that encapsulate Jira API from clients that's going to use it, and our main class is our client, and gives them this method, set up organization, add customer. So that's will be very good Python example to use this pattern. Okay, now we go to high level abstraction, and it's structural pattern. However, it's one of the rare moments where we can also think about system design for structural pattern. And that's something that's called API gateway. Could anyone raise hand if they ever heard about API gateway, about this like a layer when you work with production system? Okay, perfect. Yay, yay. Okay, so it's very, very good. So you see, basically API gateway is something when you want to, clients do not know about all existing APIs, but you get them, like you give them facade, like they do not care, like, is it product service or is it order service or what is it? They just know that all these services will be available by us, like my company product, my company card. So the path for them is all the same. For them, it's one single point of entrance to your system. And under the hood, you have several subsystems, which are your microservices. So that's a beautiful example of, again, thinking about facade in real life. Right now, we have it as a pattern in system design as a API gateway. And another example is here. I like this example because it's a popular framework, GraphQL, and that allow you to also do not think like what exactly is the service, you just invoke methods. And you eventually get the data, but you don't know anything about where this data came from. You don't know about this subsystem. You don't need to know about them because Facade as API gateway give you everything that you need. Okay, any questions before we move to the next pattern? Yes, Bubble?
I was wondering, is it similar if you do OAuth? So, sometimes you can sign in with Google or you can sign in with Slack, and then they have different flows and things. Could you also do that with a Facade?
Good question. I think authorization is more like how you get access to behavior, right? Like it's behavior, but you need to get first an access to this. So for authorization, I would say it's more decorator pattern because you decorate your API with some layer, for example, authorization.
Hmm.
So I would say it's more like decorator pattern in system design world.
Thank you.
Okay, good. Thank you for the question. Okay, so if no more questions, we can move to the next one, and this is our template method. I was thinking a lot about this when I was preparing presentation, and at the end, I decided to put this slide. So my question to you, don't you think you meet this pattern every day? Or like raise hand who think after reading all of this that they think they meet every day. Okay. Diana and Dennis. Okay. Okay, good. Okay, let's go. Let's see what will be the answers after all these slides. So let's start positioning this pattern in our 3 categories. We position this pattern in behavior because it's about behavior. Everything in template method is about template for behavior. And again, in my personal words, behavioral about creating a pattern for some behavior from scratch. Okay, I like the example in book. I was really like, okay, that's a very funny example. And I put it here as an example. So basically, also, I was really laughing on the idea, like getting what, like time for caffeine. And it's about having coffee and tea. Both of them have caffeine, yeah? And we have 2 recipes here, which is about doing some steps. And we can think about it. Actually, boiling water we need 2 times for both recipes, absolutely the same step. We need putting something in boiling water, and then we need to put something in cup, and then we need add. So when I was looking at it and their idea to explain it, I was thinking like, okay, which one I would highlight as the same things, yeah? So if you remember, now we heard about don't repeat yourself principle, design principle, you would think like, which one I repeat, which one I repeat, yeah? Boils in water, I repeat. In boiling water, I repeat, so I would highlight it in circle. Pour in cup, repeat. Add, repeat. So, and we need to follow the principle, do not repeat yourself. So how we can do not repeat yourself? That was the whole idea about template method. So basically we define some template methods that already have only one time boiling water, only one time put in something that will be arguments parameter of the method, but that will be in boiling water. We will pour in cup, and something in between will be our parameter for this template method. And we add something, again, sugar, milk, it will be some parameters. So that's how you can framework this pattern through these recipes ideas, and you can get any similar recipes and imagine in your head, okay, what if I write the program? Like, what will be repeatable things? What will be common things? And how I could build template and then create a robot that will cook it for me. Yeah, in ideal world. Maybe one day we still will be there. We will be able to program our own domestic robots that will cook for us. Who knows? Okay. So template method pattern define the skeleton of an algorithm. And the main word here is algorithm. Yeah, so if you feel that there is some algorithm that could be repeated just with different variables, just with different parameters, then you can think how to build the template method from this, yeah? And it allows subclasses redefine some certain steps for behavior, for algorithms. And you don't change algorithm anymore. So again, if you go to this recipe example, you change coffee, which is subject, you change tea, you change lemon, you change sugar or milk or anything else that you could put in these drinks. But actions, boil water, pour in cup, steep in boiling water, yeah, put in boiling water, like actions will be the same. So subjects are different and actions the same. I really like this thinking, like, okay, what is the same actions and what could be different arguments. So that can really help us when we do some things in real life. Like, again, my favorite example, any payment system. And we can think, if it's different payment system, what is common algorithm? What we do every time for payment system. So class diagram is quite neat and not too many classes again. It's template method and two primitive operations, yes. And then we have implementation of how we can execute these primitive operations. That could be get ingredients that we put in our drink to finish our drink. That could be get tea or get coffee to put in boiling water. So that's two operations that just get ingredients or get main component. Okay, there are very good comment. This one, I like the comparison to strategy pattern. Both are choosing the behavior. Yes, I wanted to highlight it as well. And before we will highlight this, okay, that's one more good question. What if we need to change steps for one of the subclasses? So you mean that basically for one of the recipe, we put there one more step in the middle, yeah, and we don't have for another one. It's a very good question. And first of all, there is disadvantage of this pattern. If your template method hidden from you, if you can't have an access to change the template method, then you're in trouble. You need to copy this template method. You need to copy the whole library or like several classes that's about implementation if you don't have an access to this and add your behavior. Yeah. So that's why when you use in real life some libraries that's already templating some behavioral for you, for example, sending HTTP request. Yeah, you just do post, but the whole open socket, open connection, put data and send data, everything is very templated. You don't need to do this. All things that you need to do is basically just do post and you can trust this template. It's very, very unlikely that you would need to change this template method. However, I met this one time. I need to copy a lot of behavior because I needed to change it a little bit for my needs. So indeed, like if ever you will meet this need, which is going to be very rare for, I would say, modern frameworks when you already use some templated algorithms. It's very rare, but if you need it, then you need to copy template method class that you don't have an access to. Now let's think about another example. You already have template class. You have an access, you implemented this one, and you need to change for one subclass how exactly that will behave. It's a good question, because if you look at this diagram, these primitive operations should be, they already should be in abstract class. But at the same time, you can add one more operation and add it in template method, and abstract behavior will be not implemented, because not any, like, you have already 10 subclasses and none of them needs this behavior. Yeah. So you could expand it and say that, okay, for this, it's not implemented. Yeah. But in this case, you will violate risk of substitution principle, because you would say that you some concrete classes implement your abstract class with some behaviors that they don't have. Yeah, so it's subtle thing, because this pattern has disadvantages. Again, like, we don't, like, nothing is perfect, and this pattern also, is not perfect, is not, and he has these problems with violating risk of substitution. Again, like, what if you have even here a concrete class that doesn't have primitive operation 2, which is mean, like, okay, that's something wrong, and risk of substitution, we out of them, and that's mean, like, maybe our pattern as template method didn't work, and we had to go to strategy pattern, and we had to find other abstractions. Maybe we shouldn't have to do these template methods at all for our system. And I saw examples in real life when they built very cool abstractions and they used these template methods, and then many implementation just said, these methods are not important. So basically, the whole idea of template method didn't work very well when it was already several implementations that did not support some operations. So they shouldn't implement this interface at all. They shouldn't have been children of this abstract class. So one of the principles they say, value composition against of inheritance, favor composition to inheritance. But template method, the ones that tell you, here you have hierarchy. Yeah, so here you have children's concrete classes, they are children's of template method. So not composition, but hierarchy. Yeah, so that's why this arrow basically it's white one. Yeah, so it's child of abstract class. It's not the one who has abstract class as a field. But abstract class, template method, hide away implementation. Now, let's see two things. First, the template method in the wild. So this few paragraph encourage you to go and check what frameworks, what some things that you use that's already encapsulate for your behavior. So go and check in wild. Yeah, and let's first go through this Raccoon book website. Again, what we have here, we have some very common behavior because they all about open file, extract data, parse data, analyze data, send report, and close file. And when we wrote it 3 times, we are realizing that, okay, maybe we can template this in one method that will work with different formats. Yes, so kind of very similar to strategy, but different thing because here you already have algorithm with repetitive tasks, with very similar tasks. Yeah, so we know that some things we need all of them basically. We have different implementations because we have different strategies how to do this, but mine is the same, algorithm is the same. So we encapsulate algorithm to one data miner, and others just implement methods that's needed for these steps. Okay, and if we go, so let's look at two sections here again. Relations with other patterns. Now we again think about our creational patterns, and we had factory method, and now we have template method. And again, the same story with Facade. Basically, you can think about them as alternatives. So we would say factory method is one kind of template method, but template method could have several factory methods under the hood, because when we say about factory method, we say about one method that's create an object, while when we say template method, we say like there is a big algorithm and all steps are the same for subclasses. So we defined one big algorithm, and that will be template method. And another thing, we had strategy. And again, we could say that they live together and they have different concepts. So strategy based on composition, because basically when you implemented several strategies, you put them in invoker, and you say like one by one, I invoke those strategies to do this thing. And template method, it uses different strategies under the hood. Even we can think about this example. So you have indeed different strategies for CSV, doc, and PDF, and that will be strategy pattern, but also a part of different strategies to open file, to extract data, to parse doc data, to analyze, to send, report, and close. For all of them, you have common algorithm to mine this data. So now you have both patterns in the same place, like you create miner, like main miner, or I don't know, master miner, and you say that it has list of miners, which will be different strategies, and all these list of miners and the interface of miner, you go through the cycle and you invoke mine, and just passes from like what passes do you need. Yes, so you basically combine these two patterns, and they can happily live together. Yeah. Okay. Let's quickly check what examples of Java and Python. And again, if you think about Java, there are so many examples. Input stream, output stream, reader, writer. They are template methods because they open sockets to read from file, and then they close sockets. So they do all these template algorithms. Then abstract list, abstract set, abstract map, and we will also talk about algorithms to work with collections in HTTP servlet class. And if we think about example here, example is about that we have network as abstract class and do the post as a template method. But how you log in into network, how you send data, and how you log out, that will be abstract methods. But post, basically you need at least to be logged in. You send data and you log out. And that's it. Post is the same for any implementation of network, Facebook network. And another one will be Twitter network. Okay. If you look to Python, I would say it's too abstract to be memorizable. That's why we would think about better examples. So let's see. Yeah, a relationship with other Python that we already discussed. And for Python example, let's think again about data exporters. Yeah, so basically we have export to Excel, prepare data, product data exporter, marketing data exporter. So they will prepare data in different way. And we would use them to export data to Excel. Yep, so if you follow again, our template method is export to Excel. Yeah, so we have some preparation and some saving basically. Yeah, and we will have different prepare data and save data. Sorry, prepare data here, but save data is not here. Actually, sorry, it says here. We don't even need to implement save to Excel because we can use it through data frames from Panda. If you have heard about it, if you've not heard about it, go to our Python coding club, and there will be some sessions around pandas as well. So basically, we just need to get them to data frame, and we're telling it in abstract implementation. Yeah. And when we prepare data, we know that we need to return them in data frame format because we already know how to put data frame to Excel. If you ever tried to put data in Excel in Java, you would be thrilled how easy it could be done in Python. And you would think how to have GraalVM in my application so I could implement it in both languages, my, I don't know, HTTP request responses, data management connections, everything in Java, but precisely this part in Python, I want to write two Excel files only in Python. Okay. Now, I really liked this example from the book. So we have an example that's basically would like to sort ducks. And they say that when we do this, we use arrays, static method sort. And all that we need that duck able to implement interface comparable. So in this arrays sort, it's our template method. We don't care what object we work this. We just care that we can compare these objects. And that makes sense because arrays with method sort, it's quite not straightforward method, and you just don't want to implement it every time from scratch. Instead of it, you want to use ready algorithm, which is like quick sorting, merging, swapping, whatever you do under the hood. But why would you implement it for ducks if you could just use template method? So that is our template method. And I like this example because they find beautiful way to avoid inheritance. Duck shouldn't be child of arrays to be able to be sorted. Instead of it, you have some interface that has methods that will be used in your template method, yeah? So that's how we can avoid this problem with inheritance, problems with list of substitution principle. We can say this is interface, and this interface allow you to do this template method. Yep. If you don't need these methods, you do not implement this interface. If you need to go through template method, exactly from this template method, you need this interface. But that's it. No inheritance, please. No direct abstract class, just interfaces, and interfaces as small as possible again. Maybe if you come to violation of Lisco substitution principle by having some template methods, and maybe it's not too late yet to separate them to two, for example, templates methods and create two different interfaces, and you would just know, okay, this one have these interfaces, and this one doesn't have. So now we have just two template methods, both lighter. And yes, there is workaround. I really like this example because it really helps you to understand how to work around it and how to avoid abstract classes, because that's what we even, I think, started this in this book. Favor composition over inheritance. So do not build this hierarchy between classes, and effective Java say whatever you could, do not use abstract classes, especially from Java 8 when you already have interfaces with default methods. So even if you end up that you need some default behavior that you could do in abstract class, instead of it, you still could go with interface and define default behavior. So let's use all tools in Java to build it very robust, easy to couple, and do not hesitate to mistake. You maybe didn't know that there will be one more method that do not follow the category of template method. Just decouple them, just see what could be workaround, and do not hesitate to try, and even if it didn't work, it's fine. You could see how to refactor it with strategy instead of template method. Yeah, like how to improve this by using interfaces and by do more different, smarter template methods instead of one too big one. Okay. Yeah, there was funny discussions and I just liked it, so I put it here. Yes, Narmin.
Actually, I have a question. In case of abstract classes, if we have concrete methods, so these methods always are called template methods, because in the subclasses we can override these methods and we can change the behavior. So is it kind of the violation of this list of substitute, or it's not a case that we always call these concrete methods our template method as a template? So because kind of these two definitions kind of seems to me opposite, but at the same time they work together. So
okay, let me rephrase the question. We have abstract class. We have method that's already implemented inside abstract class.
Yeah, concrete implementation.
Yeah, in our child, we need to change this method. So we say that child behave differently, despite we already defined this behavior part. So yes, it will be violation of Lisco substitution.
So in that case, can we again call this method template method in the abstract class, because we somehow change the default behavior?
We call it template method, and we said that template method has this imperfection because they violate Lisco substitution. It may violate. So we say that it's template method, but we come to this point where we had to violate Lisco substitution, if it makes sense. Yeah, so yeah, when you have it sort of like this through interfaces, I would say it will be a bit harder to come to this, because here you do not implement arrays. Arrays exist separately with static method, and they expect you to have interface. So here you basically can't do this.
Yeah,
that's how you try to avoid like.
Yeah, in case of interfaces, I mean, we have default methods, right, in Java. So basically, we can put these template methods there, like sort and other methods. But in case of abstract classes, we don't have this chance. That's why I'm a bit confused that we somehow, again, changing template behavior. So in that case, can we have right again call it template, because we somehow in the child classes we change this behavior.
Yeah, but if you have several other children that still follow this behavior, yeah, that's still template method for them. Just in one child, you had to rewrite it, and you had to, for some legacy code reasons, to violate list substitution, right?
Yes.
But it's still template pattern if others children do not care about it, just give it to parent, and then someone who work with abstract classes, like abstract type of this abstract class, they invoke these template methods, right? That, like, why it's violation of list substitution? Because when you do this invocation in some client that uses abstract class type, yeah, they expect that it will be all the same. But when it's the child that's implemented by themselves, yeah, there is no clue for client that it could be different under the hood. Like there could be some changes, like it could write to some file, and that could request some directory for this file to exist. And for client, there is no clue that that will happen with an error if directly doesn't exist. Yeah. So you see there are potential dangerous runtime error, but it's still template method.
Yeah. Thank you for clarification. So what I understood that it's still template for rest of the classes, even if one child class changes the behavior, right?
Yes, yes.
Thank you for clarification.
Okay, good. Yes, I like this paragraph because it's saying like, is even this one is still template pattern, and it's justify like even more like it's a like it's not a textbook template method. And why I put it here on the slide, because I wanted to highlight like don't think about patterns as something that exists in this textbook and you need super strict class diagrams to identify and follow this pattern. Instead of it, think about patterns as a concept. And how could you follow this concept? And again, we have functional languages where patterns will be different by their implementation, because we may don't have even objects in purely functional languages. But we still have pattern as a concept, as an idea of how we can build something, explain through pattern, make it more sustainable, more easy to use, and also quickly exchange ideas with our colleagues. So that's example like encouraging this one. For Python, we have very good example as Django web framework, because in Django you already have HTTP requests, and that's something that's given for you as a template method. If you work in this machine learning, you know about TensorFlow, and again, it's template methods that encapsulate algorithms for training classes, providing standardized structure and allowing customization. Yeah, and other languages. There was a question for TypeScript. So Angular framework. You could think about template method that encapsulate again everything that you need for lifecycle hooks and structure for initialization and change detection and destruction. So that's more in terms of TypeScript and Angular framework, yeah. But the main idea is that in any language you already have your frameworks, your vendors that give you some algorithms ready for you. You don't need to define algorithm how to send HTTP request from scratch. You already have template methods. And as I said, right now, up to date, mainly when you use these template methods already, they already so many times tested, implemented, run in production. So it's unlikely you would need to change their core. Yeah, like you would need to change the method itself. You can just use it. It's fine. It will work. Yeah, so now I will have this question for you again. And there one more question. Is there a standard of naming of template method like blah blah template? No, it's not standard naming. And again, template method is not textbooks. It's more like concept. Yeah. And one more question. Why did we choose to inherit from an interface instead of an abstraction class in this case? So, okay, I think, well, do you have still this method? Oh, sorry. Do you have still this question? Because we already talked like about advantage of having composition instead of inheritance. Let me know. Maybe you could rephrase your question.
This question was about when we talked about DAG and array, and as far as I understood, in that case, we decided to have an interface, and our DAG would extend
Implement interface.
use this interface. But in all our previous examples, I noticed that we mostly were using abstract classes, and so I'm just a bit confused. When do we need to use abstract class? When do we need to extend inherit? Probably.
So which one to pick up? Inheritance
Yes.
or composition? That's your question. Yeah. I would encourage to try to find out composition. And if again we will go to this example, template method, and let's go here. Yeah, so let's again think about these data miners. So first idea is to create abstract class. Yeah, let's even look at this one. That's network. Okay. Okay, let's look at this example, network, abstract class. And that's one extend abstract class network. Yeah, so that has method log out, send data, login. But we could have say that we have not abstract class network, but interface network that has the same methods, login, send data, and logout. And this post we could put not in abstract class, but in network, like, let me think how we can call it. Instead of network interface, we could have network sharing service or posting service. For example, network posting service. So with one, this will have this template method post, but it will take, instead of message, our network class, this type of network, and again, use all these methods, but through interface. Yeah, so it's the same idea of having algorithm that works with all our logins and data logout. Yeah, idea is the same, but you don't have to be dependent on this post method in your Facebook, for example, right? So you decouple them. And one of the principles is favor composition over inheritance. So I would decouple them because that means that we could have more isolated interfaces with logins and data logout and services that can post messages to network. Yeah. Did I explain? So basically post get message, but also network as an object, like what network posted to. And in this case, it could be even static method. You don't even need, unless you have something else that's where you need objects, you can even use it as a static. So it's easier to reuse. It's easier to, it's easier to manage. They could be much more independent. And if it's some case, you think like, for example, your network interface need one more method. Like your post message could have one more method, one more action. So like Facebook, instead of extending network, could implement interface network, but it could implement one more interface with one more method. And that could be used in post as optional, how to say, we can give another object option, for example, which will be a bit weird, but anyway. So we can do not post method, but another method. Yes. We could do it in the different way. Like we can say that if we need another post method instead of this one, with one more method, we can do next thing. We can do another class that will do it in different way. So we wouldn't violate risk of substitution at all. And this class will expect the object that not only implement network, but also implement some another interface. So that's how we can reuse it, rebuild it for future needs without violation risk of substitution. Okay, let me know if anyone understood what I was talking about. Or if I need to write some pseudocode so it will be clearly, because I can try to write it for you. Do you want me to write it down?
Okay, can we try if we have time?
Okay, yes.
Thank
Okay, let's do it. Where to do this? I have just a spare slide. So let's say 5 minutes on some composition. I will do a mistake, just forget. Yeah, just inherit. Yeah. Just forgive me. Then let me do next. Let me copy some textbook. Okay, let me just copy this one. So I will write it in this way. And let me change colors to this one. Okay, because I gave you so many examples. So let's think that now you have interface network. So what method was let's say they all login. So it's Boolean, I think. Boolean login. Okay, I think I even can copy some of these. Yeah, so yeah, perfect. Instead of writing from scratch. So let's say because it's interface, you don't need the keyword abstract. We just say this is our interface. Now we have class Facebook, and this is implement interface network. So let me even put it in another slide. Okay, let's put here this one. Now Facebook will be absolutely the same. That's why I will copy it. It's quite complex class here. So no worries that it's not here, just I say implement right now, right? It's just implement network. Okay, let's go next. Just to favor the example, let's say we have Twitter. That's now, instead of, again, extending the class network, it has implement interface network, because it's now interface. Okay. Now, let's put our post method. Let's put it in the class that will be responsible for posting. So it will be called network post posting, but actually we don't use AG, but so you have the idea what is it. Post service. So basically we need to execute post, and it's a like, why do you put it all in one word if this word does not exist? Yeah, so even if we remove comments, we just say like what methods we use. Yeah. Now we say network, where to post basically. Yeah, network. So now instead of trying to get them from abstraction from our class, we say we get them from object network. Yes, and data and logout. Yeah, and because we didn't create any object, we can even put it as a static. Yeah, and here we can say singleton. So if you remember, we just say private network services. I don't know, network service. Again, maybe, yeah, like basically we say new network service. So no one will be able to create this one because we say it's private. Private, yeah. Private network service. And that's our constructor. Yeah, so basically this is a singleton, if you remember creational patterns. And now you just said that we have this static method. I said just like no one could create this class. It's the purpose just to have static methods. Yeah. So that's already how we put this template method out of inheritance and used composition. Basically, it asks us post where, what network. Yeah. And now we can, like what we discussed, basically, what if we need to change something in this method? And okay, who can imagine what we can change for post? Like we log in, send data, log out. Any method you can imagine that we could change. Anything that we could add for Facebook, for example, yeah. Maybe some imagination, just if you have idea. Let's say we need something else when we do it precisely through Facebook. For example, I don't know, collect, we send data, but we also want send notification. Yeah, cool. So let's say like Twitter do not send notification, but Facebook send notification. Yeah. And here we're in trouble because we can't, notify our friends, for example. Notify 3 friends. Thank you. Notify friends. And here we're in trouble because in Twitter we do not notify friends. Yeah. Okay. So you want me also add message, notification message to this, right? It will be even more complex, but we even can try with both examples. So we want notify friends, maybe even with some data. Yeah, like okay, yeah. Okay, let's go like this. It seems like it's method of network, but for example, we don't have yet implementation for Twitter. And we don't know if for Twitter we will require this feature. Yeah, like we can't even say that it's a network, but it's not implemented for. And let's say we have so many social networks, a part of Twitter that doesn't have this method, and it's likely they wouldn't have it. We don't know. So it will be a mistake to put it in default. Like if we say that, let's put it in interface, like default notify friends, we could do this way. And we could say like not implemented, yeah, throw the exception, runtime exception. Runtime exception, yeah. This is one of the option. But if we go like this every time, we may find out that we continue to add some methods. Yeah, and default, sorry, default, I don't know, save memory. Yeah, and actually it's not good because that's some variation of list of substitution because parent has some, requires some implementation, but children doesn't have it. Yeah. So yeah, ideas that's coming next is implement interface notifiable. Let's use this one. So here we would say, no, we wouldn't do this one. Let's say like, instead of this, again, like, let's say, I will copy your notifiable one. So basically, they say like, Boolean notify friends. Oops. Okay, so it will be just an interface that's notify friends. Okay. So what we can do now? So we didn't require anyone to have this interface a part of Facebook. Yeah, so now we can say notifiable, and we say like, here we implement notifiable, notify friends. Okay, we implemented this one. Now let's think about this one. Actually, because we can check the type, like the first step, I think, that we still can do here in this template method, we can say if network instance of, yeah, instance of notifiable, which is mean it has this feature that, yeah, then we notify friends. And then how we didn't have to violate this substitution, but we still could do it even in the same method. So, okay, I will stop here because you can continue to expose it more. You can do other things, and you can think like, okay, maybe we can separate it in different posts, etc. But yeah, like that would be example how we could use interfaces to make our code base more sensible, because at the end we will find out, okay, only Facebook has this feature, but we forced everyone to have this default not implemented yet implementation, then we did bad design. We shouldn't do like this. We violated this substitution. Okay, thanks a lot for your reactions. Yeah, thank you. Okay, what we skipped before we moved here. So again, let me ask, do you feel that you meet this pattern every day? Who now can raise their hand? Okay, that's more. Okay, convinced. Perfect. And we were thinking what could be system design example for you. So Terraform is something that appeared quite recently in our DevOps world. I would say DevOps and software engineering, where you build distributed system and architecture. Yeah, so what it is about, it's infrastructure as a service infrastructure. And basically what smart minds in this world figure out, and I'm really amazed that you could configure for many different service templates that you apply for configuration. Yes, if you know, like if you heard about that, that will be our system design example for you. That's something you could build, give to your CI/CD, and also source control. And voila, you have so many different environments, but they all described this template, so you don't need like to do a lot of scripts that are similar. So that will be our system design example. And for today, that's it. We now came for facade and template method. Yeah, we actually we're out of time a bit, even more than 1 hour and a half. So again, it's the same that we discussed previous session. When you think about your system, think like what is a behavior, what is the structure, and how you could use creational patterns. And what patterns? Okay, that's another thing that I wanted to ask you before we will finish. I wanted to ask if anyone would like to share what patterns are you using so far. Like still, we started 5 weeks ago, and now you become more familiar with what is it, and depends on the language even. Let me know if you have, yeah, if you already find out that you're using so far some patterns. That's the moment for you. Okay, I see adapter and facade. Okay, thank you for sharing. And I will ask you the same next session, so be prepared. Okay, the presentation we will share in Slack. If you want more resources and inspiration, you can check how boring it's described in design patterns in original book. Think about diagrams as well. Think about classic diagrams, if they make sense, if they don't make sense. And of course, Raccoon is favorite website if you have other language. If you use some language that we didn't cover in this session, you always can check how this pattern can be implemented with your language on this group patterns website. And that's it. I'm finished this recording right now.